We map our commutes, translate foreign menus, and stream our favorite songs. These interactions feel entirely seamless. But what is the shared mechanism that allows a map, a translator, and a music player to function? Beneath the glass of your everyday screen, artificial intelligence operates entirely through structured mathematics, acting as a hidden universal language. At its most basic level, mathematics provides the structure to recognize, measure, and describe the patterns found in physical reality. Human survival and machine intelligence share a common root. Both take the chaos of the environment and translate it into recognizable, predictable patterns. Natural structures, like weather systems or a heartbeat, form effortless, repeating rhythms. Yet most of us associate mathematics with the rigid anxiety of a timed classroom test. Viewing math strictly as a test of memorization causes us to approach artificial intelligence with apprehension, treating it as an incomprehensible black box. Mathematics is a vocabulary designed to communicate relationships. It allows us to describe how one part of a system influences another. To navigate an AI-driven economy with clarity, we have to unlearn our anxiety about numbers and learn to read the structure of that invisible language. The process starts with arithmetic. This is the foundational alphabet, converting observations from the physical world into measurable numbers so they can be compared. Scaling a system requires algebra, where specific numbers are replaced by symbols like X or W. Symbolic notation captures overarching relationships. It allows us to reason about entire systems of data, rather than solving these isolated individual equations. This is the equation y equals wx. By assigning symbols to data, notation acts as a compression tool. A single line represents millions of simultaneous calculations, providing the stability for machine learning to process information at an immense scale. This chart shows how AI organizes information by converting traits like age, income, and purchases directly into a mathematical vector. Each trait becomes its own axis, transforming a list of human behaviors into a set of precise coordinates within a geometric space. In this coordinate space, distance equals similarity. The closer 2 points sit to one another, the more related the underlying data is. Groupings like action lovers and romance lovers emerge naturally based on spatial density, allowing the machine to identify patterns without human labels. This exact same logic maps human language. Words like king, queen, man, and woman are plotted as coordinates, where the physical distance between them represents their relationship in usage. AI models function by measuring these physical distances in a mathematical space, thus turning semantic relationships into geometric coordinates. Geometry requires clear coordinates, but human behavior is fundamentally noisy. Data points often overlap, making perfect boundaries impossible. This vertical scale illustrates probability. It allows machines to function under uncertainty by distributing belief on a numerical slider between 0 and 1. AI computes where a prediction lands, outputting a confidence score as a mathematical likelihood rather than a binary yes or no. This text block shows a spam filter's output. With an 85% likelihood of spam, the machine makes a probabilistic decision about how to route your email. Uncertainty is a constant feature of reality. Mathematical probability gives AI the honest flexibility required to navigate a world that is rarely certain. Calculus is the mathematics of change. It provides the core logic for continuous adjustment and movement over time. Artificial intelligence uses this logic for optimization. When a system identifies an error, it uses the math of change to adjust its internal parameters and try again. This diagram maps the learning pipeline, taking in raw data, transforming it through math, making a decision, and seeking improvement. At this stage, the machine computes the size of its mistake and slightly shifts its mathematical weights to increase accuracy. Machine intelligence is defined by this structural capacity to measure failures and mathematically adjust through self-correction. When you use a translation app or a map, you are interacting with a system of vectors, probabilities, and optimization loops. The AI generalist evaluates the fundamental structures driving a tool's output to ensure it aligns a listenistic purpose. When we apply human context, ethics, and specific cultural needs to a machine's calculations, the technical output becomes useful. A generalist acts as the bridge, ensuring the math serves a human goal. Adaptable thinkers who can interpret these systems and guide them with responsible judgment will be the ones who solve meaningful problems in a changing economy. Artificial intelligence is a mathematical translation of our reality. By understanding the grammar of that translation, we replace the mystery with clarity and take control of our future.